Hi, this is Eitan, a Pyre Square from the Twisty Puzzles forum. I've been making puzzles for over 15 years now, using techniques that I picked up from various Twisty Puzzles forum members back in 2009 and 2010. In 2011, I made Twisty Puzzles a la vie, in which I described the process of designing the mechanism of a shells mech puzzle. But I really glossed over the second half of the design process, which is the cleanup. I've been meaning to make a follow-up video on this for many years, so without further ado, let's get started. What I've made so far is what engineers call a master model. A multi-body part that consists of one of each unique part on the Twisty Puzzle. This is an upcoming puzzle that I haven't presented yet because the first version didn't work so well. But this new mechanism is looking better, and so I'm ready to start the cleanup process so I can get it printed. Cleanup is a long and involved process, and it often takes many hours to implement. This is what we're going to end up with by the end of the video. You can see each of these steps of it in the final result. We're going to insert the part. We're going to delete down to the part we need. We're going to delete faces to clean things up. We're going to move faces in a few different ways. And then we're going to do a whole bunch of fillets. So let's start from a clean part. The first two features in a parts file will always be an insert part and a body delete or keep. Insert part pulls in the whole master model file. It includes, and you can just select whether you'll include the solid bodies, the surface bodies, the axes, the planes, cosmetic threads, all sorts of things. It's pretty unusual to need anything except for the solid bodies and surface bodies. Sometimes I bring in the axes and planes. In this one I actually brought all of it in. And if I scroll back here, you'll see that it actually brought absolutely everything in, including this, these surfaces that I use to cut the parts, which are sometimes useful in the cleanup process. But in this case, I don't really need them. So the second feature is the body delete / keep. This lets me delete down to just the part I want in this file. I usually do keep bodies. You can do delete bodies, but that makes you have to select the things you want to delete. Here I say keep bodies, and I just select the one that I want to keep, which is a lot more efficient. I hit OK. When I'm starting the cleanup process, I usually save all the parts out in quick succession, and I do it like this. I start by putting these two features into the model. I do that, I go to insert part, and then I select my master model, and then hit submit, and that puts this in here. Then I do a body delete. I go up to the solid bodies folder, and I find the one that I want to keep, and I say delete keep body. You can also access that by turning on your selection filters toolbar and selecting bodies, and then you can right click here and say delete keep body. I always have this toolbar visible because it's useful. Alright, well in any case, let's scroll back. Okay, so now I've only got one part, and so what I do is I go and edit the body delete, choose the next part, and then I do a save as to the name of that new part. I'm not going to do that now. I've already done it for the rest of the puzzle. But I'm going to undo that also. But I just do that in quick succession until I've gotten through all of the parts. And this puzzle has 34 unique parts, so it kind of takes a while. But I want to get all of them into place. And then I start into the first stage of cleanup. The process of making a twisty puzzle in Solidworks always leaves a lot of faces that are unnecessarily split, like this. These are all tangent to each other, but for some reason they're split up. And that happens in several different places on this same part, including underneath and above. You can see the edges of those split faces by going to View, Display, Tangent Edges Visible. I'm very used to seeing these things, so I actually keep the view of them off. I'm very used to knowing that they're there, but for this tutorial I'll put them on because it helps you guys see it. What I'm going to do is a rather finicky feature, but I've discovered some good tricks to make it work pretty consistently. Right-click on one of the faces and click Delete. It's under the Face section. You may need to expand this. So click Face Delete, and now you're in the Delete Face feature. And then you select all the faces that make up that split face, except for one. The exact one to leave behind doesn't exactly matter, but I've found that SolidWorks can be kind of picky about this. You have to do some experimentation. Actually, occasionally, if you just select one of them, it'll work, but that's only if the other ones are completely disjoint. But in any case, show preview sometimes works, sometimes it doesn't. So, but really, the point here is you select Delete and Patch, and then you hit Enter. And now we're left with a single face. That's the goal. You want to have a single face on each of these. So I'm actually now going to go back into that Delete Face feature and move on to my next one. And try that and hit Enter. Good, that one's solved. Now occasionally it won't, in which case, this is why I'm only doing it one face at a time. But if I go like this, it may not solve. Oh, it did. Let's see if I can get an example where it doesn't. Okay, well, we'll see if we come across one. But in any case, the goal is to end up with each of these things being just one face. So I'm going to quickly go through that right now. And again, I'm checking each time to make sure. Let's see if that works. Aha, there's a time when we get a rebuild error. For some reason, it doesn't like this, so I'm going to try that. Great, it liked that. All right, so we've got one face on each of these. Delete face is also useful for slivers like this. I've opened another part to show it. Without deleting that face, there's just this little sliver here, and that's going to make fillets really complicated. And so what I do is in my delete face feature, I also include this guy, and now it ends up straight. And the fillet that I'm going to end up putting on this edge is going to just blast right through the material that I just added, so it's no big deal. And you can even get away with it on something like over here. I've actually already gotten away with it over here, so I got rid of this sliver as well. So it's very useful. It makes the faces that are next to it extend until they meet each other. You see that? So they come to an edge like that, and that makes it so that I only have to select these guys in order to fill it. So let's move on. Let's go back to the other part. Okay, so we're back here. Gonna hit save. Always good to save a lot. Once you're done cleaning up faces, it's time to move on to clearances. A shelves mech puzzle needs to have clearance in specific places throughout the mechanism. You may have heard this called tolerance, but as an engineer, that word means something completely different to me, so don't get me started, just call it clearance. In this video, I'm not going to go into why I pick certain faces and leave others alone. That's a topic for another video, which I might make someday. But what I'm going to show you in this video are two very important steps that will help make fillets more streamlined later. All pieces should have a move face feature for clearances. I usually do 0.3 millimeters for SLS puzzles. I'm going to put the clearances on this face and this face. There might be another one that I end up doing a little later. I haven't worked all of them out for this puzzle yet, but let's just assume it's these ones. So I do flip direction. .3 millimeters. And so you see he's going to shift this face upwards and this face upwards. And since we already deleted the faces, since we deleted that, it's actually going to make this a lot simpler, because before deleting those faces, notice we would have had to select 4 things on this face and 3 things on this face to get the same result. So doing those delete faces makes this step a lot simpler. So I'm going to unsuppress that so that everything solves. Okay, now many pieces, including this one, will need a second move face feature for a different reason, but let's skip it for now, and we'll come back to it when we realize it's needed. Now it's time for shells. This is probably the best place in the model to shell if needed. If you're doing SLS, it's good to shell the parts to about 0.8 millimeters to 1.5 millimeters to save material cost. If you're doing FDM, completely skip shells. I like to shell before fillets, and just to make sure that my fillets are never bigger than the thickness of the shells to avoid any self-intersecting geometry. I'm not going to shell this part at all, since it's already super spindly, and it really doesn't need to be any lighter. So let's move on to the star of the show, fillets. For my puzzles, I like to do my fillets in 5 stages. Prep fillets, radial fillets, shell fillets, reinforcement fillets, and face fillets. There's a lot of nuance to how the fillet tool works, and it takes years of practice to understand what makes it break. In my nearly 2 decades of designing puzzles, I've come up with a workflow that's pretty resilient to minor mechanism updates that I may need to make, and it really cuts down on the number of fillet features in each file. That saves me a ton of time. So this is the order I usually do fillets in, but let's actually start by explaining shell fillets, as it will help motivate the reason I do these after I finish prep fillets and radial fillets. These are shell fillets. Shell fillets are the convex fillets that go on the curved edges of each shell. You could start with these fillets. So you could start with these, say 1 millimeter, but there's a few problems with them. First off, it involves a lot of clicking. No one likes a lot of clicking. Like, I have to click each of these individually. Second, you can't use a single fillet feature to do this edge right here. You can do this. Oh, you can't even do that one. Fun. This will actually make it break because these 2 surfaces are co-radial, and it doesn't like that. So we need to fix something there. And finally, selecting a lot of individual edges makes it a lot more vulnerable to rebuild errors if you make even minor changes upstream. So the way we minimize the number of clicks during shell fillets is by carefully preparing the model to take advantage of a thing called tangent propagation, which is this checkbox right here. But I'm getting ahead of myself. Let's rewind back to right after our move face feature and talk about prep fillets and radial fillets. In most twisty puzzles, there's usually this outer section of the cut, these faces right here, where the transition to that part of the cut results in edges like these, where these are conical surfaces. These might be conical surfaces, but these surfaces towards the outside aren't actually coincident with the origin of the puzzle, usually. And so that creates this little transition here. And I like to fillet that first. So the first fillet I do is usually a 1mm transition fillet right here. So let's fillet these guys. And we have a little bit of a, so this, there's a, oh wait, that was 10mm. Hey, one still won't solve. Okay, fun. For this one, we turn off tangent propagation, and now we'll solve. Okay, cool. Again, nuances. So some of these pieces will actually have a concave edge right here. Putting a concave fillet on it. I'm going to go back to that file I had open, that other one. And you'll see that the first fillet I put on here is a concave fillet. Let's ignore this guy. So right here is a concave fillet. You might be surprised that I put a concave fillet on here. Won't that interfere with the piece that's next to it? But don't worry. There won't be any interference with the part next to it as long as it has a convex prep fillet of equal or greater radius in the same spot. And it will, because these are really helpful for simplifying the rest of the puzzle cleanup down the road. So let's go back to that other piece. So now we've got those prep fillets right there. And let's move on to the meat and potatoes of the filleting process, radial fillets. This is the step that's going to require a lot of clicks no matter what. And it sometimes requires more than one fillet feature with different radii. I start by trying to put a 1mm fillet on every radial edge I can. On puzzles with fewer parts and puzzles with bigger parts, I've gone higher, 1.5, 2, sometimes even high as 3. Some of these edges down here, I might try to put a 2mm fillet on, but let's just do a 1mm fillet as everywhere we can. Now, notice this little window that keeps popping up every time I click on something. That is called the selection assistant, and it's actually really useful. When I hover over these buttons, it highlights different groups of edges. So some of these are a lot less useful. Like this is all convex edges. That's too many edges for right now. It won't solve. This is all edges. These right feature, left feature, internal to feature, those are a little bit complicated and I don't really use them often. What I really use often are connected to start face and connected to end face. They don't always both show up, but what's nice is notice I clicked this edge and it's saying that these other 3 edges are connected to that start face. So I'm going to click those and it's selecting all 3 of those. But you know what? I don't really want to select those right now. I think I want to use a smaller fillet. So for that area, because it's eating away at a lot of it. Notice I'm going one edge at a time, except for these, selection assistant things. But I'm going one edge at a time to avoid things that are going to break my model. Because if these yellow previews disappear, it means that the last thing I clicked made this feature not solve. So I'm going to actually skip these guys and maybe do these ones. See, all the previews disappeared. That's probably because these made these edges ate away at my model. Okay, so what I'm seeing is that these guys are going to need smaller fillets over here. So I'm not going to worry about these yet. But I think I can do this one, this big one here. I want a 1mm fillet everywhere I possibly can. Alright, so now here is the benefit of doing that prep fillet. Notice that before that prep fillet we would have had to select both of these. But because we have tangent propagation checked, it's going to actually spread across the rest of this edge. And I only have to click once, where otherwise I would have had to click twice. Every click matters. It's nice to skip clicks when we can. So I'm going to do these. I'm going to do all of these up here. All these radial ones. And notice it propagated all the way down through here because I have this fillet here. Okay, and maybe I think I might do these ones. Oh no, it's going to break. Alright, now when something breaks, what I do is I actually lower the size of this fillet and I watch as it kind of sweeps through this. And I try to understand why is it breaking. The reason it's breaking is because the fillet is about to cross this point right here. Right there. And so that's what's going on there. So I'm going to unclick that one, and I'll do that one in a second fillet feature. You hit enter, and let's do another fillet feature at 0.8. How about that? And, oof, this puzzle has a lot of small pieces. So I'm going to do these guys. Oh, that's better. Ooh, it still doesn't like that. Let's we go down to 0.7. Sure. Alright, I think that's everything. That's all my radials done. And so let's move on to shell fillets. Because of all the preparation we've done already, I can usually do the shell fillet in a single feature with very few clicks. So, see how when I click one of these edge segments, it does the entire shell edge. That's because we already put in these radial fillets, and so tangent propagation makes it select the whole thing. This is great, but I can do even better. A good thing to know about Solidworks is that it is much better at keeping track of faces than it is at keeping track of edges. So, for the remainder of the cleanup steps, I'm going to find every opportunity to select faces instead of edges. When I select a face, the fillet tool will throw a fillet on any sharp edges connected to that face. Since I already put fillets on these two edges, that just leaves the shell edges connected to that face. So I just have to select that one face. I'm going to do the same thing up here. Select a face. Same thing right here. And this is a little bit iffy, selecting a fillet face, but you know what? I'm going to do it. Uh-oh, something broke. Interesting. Well, let's reduce the size, see if that helps. Huh. I went down to 0.1 and nothing helped. So let's bring this back up to 1. And unclick. Okay, we're back. Well, that's weird. Huh. Okay, the reason that it's breaking is because of this point again. Remember I said that many parts will have not just one move face feature, but 2 move face features? This is why. Let's roll back to that part of the cleanup. And add a second move face feature right here. Anywhere that we don't add clearance, let's check to see if there are 2 faces that meet at a single point because they're co-radial. I see one right here, and I think that's the only one. Some pieces have lots of these. So what we're going to do is we're going to move this face. Let's make it 0.5 for right now, just so you can see what's happening. So what happened is I shifted this face downwards, and that created a new edge here. So now when I fillet this edge, it now knows what to do with it. Let's scroll forward to our radial fillets, or past our radial fillets, and edit the shell feature. Sorry, edit the shell fillets. So now we can select this guy, and it will fillet, and we can select this guy, and it will fillet, and we can select this guy. Oh, let's not select that because I want to do something special up top. For this one, I'm just going to break down and select an edge, such as life. It's going to be okay. But yeah, okay, so. That left this behind. But we can do something about that. Notice that it has 3 segments to it. This is a radial edge that didn't exist before. So what we can do is we can go to our radial edge, fillet, and add these guys to the fillet. Yeah, that's probably the right one to do it. And now our shell feature, our shell fillet, makes that a lot prettier. Now what I might want to do, since that's really small, I think I'm going to make that a teeny tiny fillet, actually. So I'm going to take these guys out of here. This fillet doesn't matter to the mechanism, so I'm just going to make it not a sharp edge, because sharp edges are stress concentrations. I don't know, 0.4. Cool. So that's leaving a good amount of material behind. 0.3. Cool. And then wonderful. Like I said, sharp edges are stress concentrations. So let's move on to the 4th kind of fillets that I do, which is reinforcement fillets. I look at the part and I think about whether it's going to break. I sometimes open the measurement tool, which is in evaluate measure, but I have it set with an easy shortcut so that I just click N, I just type M and this comes up. But I do things like measure from here to here, see what it's like. That's like 1.6. That's iffy. I can probably make it work though. But I think I'd rather have a fillet there. Okay, time to add some reinforcement fillets. Put one here. Oops, there we go. I like to keep these around 0.5 or 0.6 millimeters, just so that when they interact with the convex fillets on the other pieces next to them, they won't interfere. But this is probably very helpful already, just 0.5 millimeters for a puzzle like this. So this should really help strengthen the part. And notice I'm selecting faces and not edges because I can really get away with that here. So there we go. Alright, moving on to the last type of fillet, which I call face fillets, because it's the outer face of the puzzle. I save these for last because they're cosmetic, and there's a slightly nicer way to do these. And for these, I use a special tool called the face fillet tool. I go to the fillet tool, and instead of clicking on this type, the constant size fillet, I go to the face fillet tool. And that's because on some puzzles, not specifically this piece, but on a lot of pieces, there will be different dihedral angles between the faces, the outer face and the radial faces. on the pieces, and that will make the fillets be different sizes at different edges. So what I do instead is I use a chord width fillet, which keeps it consistent from one face to another. Now, it does complicate stickering a little bit, so your mileage may vary with this. This may be overkill, but I like to use the face fillet feature, and I think it's something worth looking into if you're running into problems where just simply filleting the edge with a constant size fillet causes you problems. So there we go. This is a fully cleaned up piece. I'm going to turn off tangent edge view because it looks pretty good. This part is ready to be printed. Time to move on to the next one. I hope this tutorial was a helpful deep dive into the inner workings of Solidworks for Twisty Puzzle design. Thank you for watching, and happy puzzling!